So, hello. So, this will be one of our last topics for this semester, and I will divide this lecture into two parts. With the first part being the introduction and stuff and related to it, and the second part are example programs. Example uh, code or write-ups for uh, several subtopics for the commands and processes of this C++ programming language. So, to start with this topic overview, we'll have the introduction of C++, the history and evolution of the C++ language, uses and advantages. Also, we'll have the general structure of C++ program section, and also discuss identifiers, variables, and constants. So as a short maybe introduction how this language was evolved and who are the creators and also the story. It is a general programming language, the C++, which was created by John Stroudstrup as an extension of the C programming language, or we call it the C with classes. So this language expanded significantly over time, and modern C++ is now has become object-oriented, generic, and functional features in addition to its facility for low-level memory manipulation. So this is almost always implemented as a compiled language, and many vendors provide compilers for this one, including the Free Software Foundation, the LLVM, Microsoft, Intel, Oracle, IBM, and so it is basically available in many of the platforms. So it is a powerful general purpose programming by its structure that supports procedural programming as well as object-oriented programming. So it incorporates all the ingredients required for building software for large and complex problems. Can be treated as a superset of the C language because the developer of this language has basically retained all of the features of this of its predecessor. So for a brief history, with the can have similarities of what we discussed with the introduction. This was again developed by Jarn Strostrup at Bell Laboratories, starting in 1979. So this attempt is to add object-oriented features plus other improvements to C. Its early term was that it was called as C with objects. So as the language developed, Strostrup named it as C++ in 1983, and the name C++ suggests C incremented, or recall the plus plus is an increment operation sa one of the increment operators of C. So, amo ni ang symbol, and it was also called as C incremented. So C++ was made available outside Bell Laboratories in 1985, and the first compiler which commercially released was CFront. It was uh, out in 1995. It was only a front-end compiler for C, and the American National Standard Institute, or the ANSI, has formed a committee to precisely basically used for the C++ in 1989. So for its precise description of the compiler language, it was developed by this committee formed by the American National Standards Institute. So its uses is basically for developing computer software. So programmers use it to develop computer software, while some for creating general system software, and also for building drivers for devices. What we have lectured before, peripheral devices. These driver programs was also developed by using this C++ language, and also for software for servers. The software for servers and software for specific applications also caters the C++ language as its core backend code. And of course, not only for specific work usage, but also for creation of video games has also been covered by this programming language. Now, its advantages, it has many basically. Some were already mentioned in the introduction. No? So it's a low level and a systems programming language. And given that it has a large community, so the support and features and development was also catered in a large scale scenario with this community that helps in the improvement of this language. And also it has been a relatively clear and mature standard, and one of its other features that it's being portable in its portability. It's a platform independence which allows the user to run the same program on different operating systems and interfaces at ease. It also has become reusable and readable, hence these two terms were also added as an advantage, reusability and readability. And given that it's compatible with the C program, its previous core programming language, so every error-free C program can be considered as a valid C++ program. And also it has become object-oriented as mentioned in the features in the introduction of this computer language. Now for the disadvantages, one of which is that it is global or local for the data. And its emphasis is on instructions but not on the data. And it can be generally heavy if not careful in how you would construct your code and how it will run later on. So global data does not have opportunities given with its feature of having global data in its variables, and it has an absence of a garbage collector. But what we mean by this term is that it is a feature that automatically filters out unnecessary data and frees up memory space. So this is also an important aspect sort of for some of the recent programming language that is applied, but this is still not yet supported by C++, so it has been considered as a disadvantage in using this language. So for a summary as reference from this website, the Flare, of the advantages we have 8. So we have this common terms: so mutability, object-oriented, multi-paradigm, low-level manipulation, memory management, and large community support, compatibility with the C language, and scalability. And again, then disadvantages: using pointers, security issues, absence of garbage collector, and absence of built-in threads. Now for our general structure of a C++ program session, this is the important part where you should need to be familiarized in how you would build up a basic C++ program. But the problem is since we don't have yet a software to use to verify it, so we'll just rely on how the specific code should be structured so that we would avoid any error in the output once we get to run it on its actual C++ program software. So we have basically 5 program sections and structured in this C++ program. So the first one is the comment section. The next is the preprocessor directives, and then it's followed by global declaration section and the void main section where the local declaration statements are enclosed, and the other functions as required depending on how this program is set up. So to visualize the actual code, as mentioned in the 5 sections, now this is one. The first part is a comment. It is enclosed in double slash and the slash asterisk. insertion, and it's followed by the processor directive, wherein include the command is the include command to add this preprocessor source for uh, running the program, but we'll just delve into it later and explain on this function. Now the main function name, so this is the main usually, and then we have the begin block and the function body wherein we put out the statements of commands and other inputs or variables are needed here, and then we have the end block. So this is another description of with the same output man, but we'll have these comments header file as added in the include. Again, the preprocessor directives, and we have the main function using the int main, and the output here is the cout using this command to put out this output, the hello world, and we use also the return statement and this braces basically for the open and close symbol for the between the main function. So to describe again, section 1 comment, this is optional basically, but it contains a description of the program, so it is a common practice to add this text to describe this program that you made to other users. So section 2 contains the preprocessor directives. The frequently used directives are include and define, and these directives tell the processor on how to prepare the program for compilation. The include directives tells which header files are to be included in the program, and the define directive is usually used for associating an identifier with a literal that is to be used in many places in the program. So basically, the declarations should be added in this part. For example, this literal in case that it is to be used again or mentioned again in the later part of the program. So it is associated then in this define directive. So section 3 again, the global declarations can be an optional part. So these declarations usually include the data items which are to be shared between many functions in the program. So it also includes the declarations of functions. And the main function is the important part. The execution of the program always begins with this execution of the main function. So this main function can call any number of other functions. So and furthermore, those function can also goes with the other functions that can be called to perform its use within this main function. So lastly, section 5 also optional for other functions as required can be also be added below that main function. So for the header files as included earlier, no, the .h files or headers are these libraries of code that you may insert in your program, including them by reference in the top block. So this example, hashtag include, and then open design studio.h, also add include iostream.h. So in this example, we added iostream. This is the input and output stream header file, and wherein you can use a cout or cin under this header file for this function. So for studio.h, stdio, this is a shortcut for the standard output and output header file, and examples are printf and scanf. It's also the same, you have similarity functions, but if combined with other functions for its ideal use, then you can basically exempt them for its proper use, as I mentioned in comparison to the standard input and output, as to this one, the input and output stream header file, in comparison to the two. So the type of header files, again, the input and output na stream.h. Then we also have math for if you needed to use mathematical formulas in your main function. And then we also have string.h, wherein the C++ has no built-in string handling, but you will use this library to copy strings to find the string length and etc. So for the studio.h again, you will it has similarities to standard library, the stdlib, but also some file functions such as printf or scanf using the C language. Now for the main function, this is where the code execution begins. So this is basically the basic structure in main open close parentheses. Then we have this symbol. You insert most of the commands here, and then you have to return 0, uh, semi semicolon, and then the close symbol. The same with void main, the same setup niya, open symbol and close symbol. So for the return statements, those are needed. So by its function on terminating the execution of the function and returns the control to the calling function, or in this case, the main function, which transfers control back to the operating system. This is recognized when you basically run this program, run the one I mentioned earlier for the Hello World output. That is, you need to add the return statement after that main function, so it would uh, again transfer the control back to the OS, and then execution resumes in the calling function at the point immediately following the call. Now for identifiers, variables, constants are definitions of these terms and identifying how to use them within your code. So an identifier is a name associated with a variable and a constant, and usually limited to these types of characters, letters, digits, and underscores. A variable are identifiers whose value may change during the course of execution of a program. And usually variable represents memory location where you can store values such as characters, numbers, and pointers. The same with the function in sa math, no? You use variables to define a certain number. So in the same in applications yung C++ programming, it represents a memory location where you can store your values given the characters, not only numbers but also characters and pointers are stored in this variable declaration. Now for the constants, these are identifiers, but these values, they are also called as identifiers, but these are values that uh, remain permanent. They are kept permanently for the program to use and remains unchanged throughout the program. So the naming convention rules for identifier, it must begin with a letter underscore. So only letters A to Z, the capital letters A to Z, small case letters A to Z also, and then digital numbers 0 to 9, or the underscore may follow the initial letter. So this is an example of an identifier. Some of squares, these are the spaces are represented by an underscore, or this one box underscore 22A, or just the basic capital letter G, and get tapos capital letter D without the space or underscore between for the data, and then the overall identifier is named as get data. So again, using numbers, digits, and underscore, which means that having blank spaces cannot be used in naming your identifiers. So having this example, get data can be an identifier as blanks are not allowed in identifiers. So basically, it will produce an error once you get to run it in your program. And identifiers cannot be reserved words. Let's say reserved words are keywords that are used in reservation for the system. For example, an int ang int, small case int cannot be used as an identifier as it is a reserved word in C++. It represents a command or a method in the program. And fourth, identifiers beginning with an underscore have special meaning in some C++ systems, so it's not best to start your identifiers with an underscore. Although it is allowed, but it is not advised to have your identifiers with this one. And most C++ compilers will only recognize the first 32 characters in an identifier, and they are also case sensitive. So C++ will distinguish between the upper and lowercase letters in identifiers. So make sure that each identifier should be constantly named as you create your program in the back end. So this is an example of grade and grade, given that this one is uppercase G. These are different identifiers in its basic sense. And also avoid excessively long identifiers. So the next convention rule again, developing your own conventions like below. So these are single word identifier can be written in lowercase only. Examples are grade, number, and sum. And for an identifier that made up several words, the first letters will be lowercase, and then the subsequent words will begin with uppercase. So an example is string type. So you will notice string is the S is small case or lowercase, and then the next word is T. For the next word, the start of the next word is in uppercase. Also with passing score, lowercase, uppercase, and largest number, lowercase and uppercase. In identifiers, used as constants are used often fully capitalized. For example, pi or max strength, maxstrlen, or this short. I think this is shortcut for max string length is used for constant. So it's best practice that you'll have to fully capitalize each constant used for identifiers. Now for declaring variables and constants, a C++ variable is declared by telling the program that the data type to be used and the name of the variable. So the syntax is data type and variable name. For example, this integer is data type and the variable name is this one. So after declaration, you'll have to need to add a semicolon on the end of this command line. So for the declare more than one variable of the same of the date type, you would have this set up. So this is the declaration. This is the data type, and then the variable names are separated by comma. So A, variable A, comma B, comma, and C, and then the semicolon on the end. So, and constants are expressions of the fixed value. So in the declaring constant, you will have the syntax and using the define command. So we have syntax of hashtag define, constant name, and then the value. So for example, we have define the pi value in math also 3.1416, but this one was declared as 3.14159. So that is the value of this constant named pi or pi. Now for declaring constant in data type, so using constant command, const t, then have data type, and then the constant name, and then equal, tapos ang value, added number or any integer can be, or value or character can be added here. So constant name equals the value and then semicolon. So example, const t, or const and int, then they use the constant name as path, path equal to 100, and then the semicolon at the end. For initializing variables, you can done by appending an equal sign followed by the value to which the variable will be initiated. So in this example, type identifier equals to initial value. So int identifier a is minus a when the initial value is 0. So usually the initial value is the starting value of this command. For an example that you would have the mathematical equations to be used in the program, then you can have initial value of 0 as its starting value. Now for local and global variables, given that they are declared within the program inside the main function, a global variable is a variable declared in the main body. It's the main body of the source code outside all of these functions, whereas a local variable is the one declared within the body of a function or block. So using this sample command, under the int main function, the global variable is the int a, described as letter a. Then this is a variable, says this is a comment, no? This is a variable, and then this local variable is within this one integer call area. This is also a command, and then int b, comma and c, these are local variables that are declared within the function declaration of the main function. So you need to identify those two. And then we have keywords. These are predefined reserved identifiers that have special meanings, and basically they cannot be used as identifiers in the program. So example are void, main, and float, but there are a list later on which you can use as reference for the setup of the keywords as the terms that you should avoid to use as identifiers. So basically that's the first part of this computer C++ computer language lecture, but later on the second part will have examples applying the rest of the topics listed in our syllabus. For example, using the Boolean functions, the arrays, the if else, the other statements, the conditional statements that is applied, and also we'll have the program development cycle, a sort of a detailed version of what we have declared lectured last time for problem solving, no, using a computer. But this one is on the level of the program development, which also will also include this on the second part, a sort of semi recap and detailing on how a program is developed and tested and debugged, and what other items needed. So that's about it for this part. No, uh, for the second part, we'll just have it recorded again with some of the samples for your reference. So again, thank you for watching.